So the only question we have right now is about call, bind, and apply, which actually, to understand this, we need to know about this in JavaScript. So let's see if anyone needs this. And then what other questions do we have today?
I wanted to talk about port numbers, how you use port numbers, what those really are.
Okay. Any other questions? No?
I mean, I feel like I'm just getting into like the HTTP stuff, and I don't know enough to ask the questions kind of at that point. So.
Okay. How's everybody feeling about their understanding of this in JS? Okay. I'm going to kind of try to smash these things together, and I'll probably try to take about 20 minutes to talk about this, 25 minutes maybe. Okay. That's actually probably the worst named JavaScript file, this.js. Okay. So here we go. So here we have a function, and we're going to call it in. And the only thing this function is going to do is it's going to console log arguments, and then in JavaScript you have access to this special object, or variable rather, called arguments, and it basically captures any arguments that were given to the function, even though you didn't declare that you wanted some argument, right? So if we come down here and we say inspect 1, 2, 3 and inspect dog and inspect an array of 10, 11, and 12, right? So we've got these three things here. We're going to do node to run this file. And you'll see that we just get a log of arguments and then an object that kind of is like an array. The 0 is the first argument. The 1 is the second argument, right? So you can access arguments like an array, right? We can come here and be like, okay, what's the first argument, right? Okay, so this function is meant to illustrate what is being given to it. Another thing that you can give to a function, right? Or rather, another thing a function has access to is the value of this. So functions have access to arguments, this, and scope, which are variables that are inherited via scope, right? So anything that you can access inside of this function is going to either come from an argument, or it's going to be the special case of this, or it's going to be something in scope. For example, let's just call this okay, so let's take a look at when we run this inspect here. We actually get a ton of output here. And that's because when we first run it, when we first run line 13, it logs 1, 2, 3 as our arguments. Everyone see that? And then this ends up being this huge output. And that's because that object that is being printed is actually the global object. It's actually the value of this when we run this function is the global object. So this is what I want to talk about, is how do we set the value of this? Okay? So by default, the value of this is the global object. Okay? Under strict, under use strict, default, this is, I think, null or undefined. So what do I mean by use strict? Well, in JavaScript, we can say, I think it's just use strict as a string at the top, or we can do it also inside of a function. But if we put that, that's a special hack indicator to tell the interpreter to do a little bit of a different type of JavaScript interpretation. And so we see this is now undefined. Okay, so that's the default behavior of this when you just create a function like you normally would and then you call that function. There's this difference between what JavaScript normally does, where this is the global object, and what we prefer it to do if we could improve the language, which is what useStrict is trying to do. It makes more sense for this to be undefined in the case of just a straight up function like this. Because this is meant to represent a ranging value that kind of represents the instance of an object in some sense. Okay? But I'm not going to talk about that because I'd have to get into constructors to get into that. I'm just going to talk about all the different ways that you can tell JavaScript what the value of this is, okay? And that is via call and apply and bind, okay? So let's look at call. If I do inspect.call, actually let's start with apply. Apply is the exact same. I'm going to actually refactor all three of these. Let's do console.log normal calls. And then down here we'll say using apply. So down here we're just going to say .apply undefined like that. So what apply does is the first argument is the excuse me, the first argument is what you want the value of this to be. The second argument is an array of what you want the arguments to be. So just like on line 15, we want argument 1 to be 1 and 2 to be 2 and 3 to be 3. Down here, we're saying here's an array of our arguments. The first item in that array should be the first argument, right? Here we get a little confusing because the first argument of our array is an array itself. So that might be a little confusing to read, but you can see here, it should make sense here. There's one and only argument on line 17, and that is an array. And that's what we see logged here, right? Which is that the first argument that we got was an array. So we should see the exact same output here using apply. And they look exact to me. So the difference here is that because we're using strict, the default value of this is undefined. And then down here, we're explicitly setting the value of this to undefined. And we get the exact same output. But what if we set the value of this to be the number 42? Or 52. Now we see the value of this is that number. Okay? So this is a way we can explicitly say this. It's basically just like setting this other special argument, right? The value of this is this sort of other argument, this one-off special argument that functions can get. Okay? Does that make sense?
I think so, yeah.
Okay, so here's where I'll show some real world cases as to why we would want to do this. But let me just talk about a call, for example, because it's exactly the same as apply. It's just slightly different, which is that instead of the second argument being an array, it just takes any remaining arguments. And I'll give this one 99. Oh, sorry, I actually have to change this to call. And you'll see that we get almost the exact same output, except the value of this is 99, but the arguments are all the same. And so the difference between call and apply is just apply takes an array of arguments, and call takes all remaining arguments are sent as the arguments. So it sort of shifts off the first argument, takes that as the value of this, and takes the rest, okay? But why would we want to do this? Why do we want to call a function and give it the value of this and give it a bunch of arguments, okay? Why would we want to do that?
So if you're trying to, from what I understand, if you're trying to access the properties inside of an object to call inside of your function, and you want to temporarily link the function to that object, that's what you do.
Okay. Temporarily link, right. Just for, yeah. Pretty much. So let's try this. Let's say we've got a blog site, okay? And in here we are going to have some users, Okay, and then down here we are going to have I don't know, let's just say print hello message. Okay, and this is a function that takes a user and we'll console log user.name, and we'll just put this and we'll say hello user.name, how are you? Okay, and then we can come in here and we can say like print user message users for the second or the third user, and we're going to get hello Shaka, how are you? Right? Everybody makes sense? So what if we wanted another way we could do this rather than pass it the user, we could say we're going to think about the user as being us, okay? And we can go on to a user. We can actually go on to all of these users here, and we can say print hello message dot call and or apply here. We'll do both. And that works too, right? Because instead of passing in the user as an argument, we're just saying that the value of this is the user, and it becomes this.name, right? So this is the same thing, right? We basically called this function and we gave it a value, and it used that value in its execution, okay? One is a lot more clear. It's a function with an argument. We should all understand that. We can pass user in as an argument, and we can say user.name. But the this.name, why are we doing this? Why is this here, right? And the reason it's here is because there's actually another way you can declare what the value of this is, and it's actually a little bit more implicit. This is an example of explicit declaration of this, okay? This, for example, are examples of implicit declaration of this, right? We didn't explicitly say what this should be, but this was undefined. Okay, here's how we would say what this was in a different way that was also implicit.
There's a typo on line 22.
Thank you. Okay, so I'm creating a new object that just has one property, name. It's got my name in it. And then I add the property inspect, and I give it the value of the inspect variable, which is this function. I'm actually not going to call this inspect. I'm just going to call this like whatever, dude. It doesn't matter what this is called. Okay, what you should see when you read this is that inspect is a variable that contains this function. This line of code takes the variable's value, which is the function, and assigns it to the property on this object. So now Jared.whateverDude is this function, okay? So it doesn't matter what it's called. And then we call that function. We're literally executing, these parentheses are executing this function, just like these parentheses are executing that same function. So line 17 and line 23 actually execute the literally exact same function. They just do it in a different way, and look at what we get. Okay, the first three executions are like this, where we have, we log the arguments 1, 2, 3, and then dog, and then an array of 10, 11, 12. We can get access to our inherited variables, and this is undefined. But look at this last one. No arguments. The value of this is Jared, which has the name and the whatever dude property, and we still have access to our variable up there, okay? This lexical scope variable one we can ignore. Okay, so check this out. Just by calling this function this way as opposed to this way, we change the value of this. So what's going on here? How did we change the value of this? What's the difference between line 17 and yeah, let's just look at these two. What's the difference between line 17 and line 23? Why do we get two different outputs here? Why is this different? Anyone know?
Because it's not referring to the the object, and you change this whenever you did that assignment to whatever.
No. Thank you for saying that, because it's good to point out that that is not where the value of this changes. So because, and I can illustrate that by coming down here and putting down another call, right? So check it out. We have 3 now, right? The first one, this is undefined. The second one's Jared, and the third one's undefined, right? So I can continue. So actually, another way to say this is this function object never changes. Once you declare a function, it's immutable. So we're not changing functions. This is all about how we call the function. So when we call inspect on line 17, there is no something dot. But on this line, there is a Jared dot. Okay? That's what's different. When you say object.property and you execute that function, JavaScript interprets this line of code differently, interprets line 23 differently than 24, and it says, okay, I'm going to call the function that's inside object property, right? So take what's inside of this object property here, execute it, and make this the value of this. Make the object itself the value of this. That is implicit in this line of code. That's part of the language. Is when you say object.property, execute the property as a function, or execute the function inside that property, JavaScript will do this implicitly special thing where Jared becomes the value of this. All right. So now we can do this thing here over here. We can say okay, and I'm just pushing around the same function. Okay, and at the bottom here, we got one argument of hi there. The value of this is now the Shaka object, which has a boosh, and we're executing that same function. Okay, so the reason why when on line 28, when I executed the inspect function that we defined at the top, the reason why the value of this was the Shaka object was because I said Shaka dot, and the property doesn't matter. I said Shaka dot something, and I executed that. So that means that function's value of this is whatever that object is. This is super implicit. It's not very obvious that this is going on here, but it is important to understand that I can take this function, right, and I can put it into some other variable, and I can call it okay, and now again I have an example where the value of this is undefined because I didn't say object dot something. So it doesn't really matter how you get a reference to the function or where it's stored. The calling is what matters. So if you call a function without an object dot, the value of this is either going to be undefined or the global object, depending on if you're using useStrict or not. But this is the main difference that you want to take away from this. The difference between calling a function without an object dot and calling it with an object dot. One sets the value of this to be the default, which is either null or the global object, and the other one, the object dot, sets that object to be the value of this.
So line 17 is the same as doing global dot inspect.
No.
It's not.
No, this is not a global variable. Oh, but I see what you're saying. I see what you're saying. If it was, if we did say global dot, you know, if we put this function on the global object in a property, and then we say object.property execute, even though we're using strict, we still get that giant global object because object.property execute sets that object as the value of this for the execution of that function. Okay? You still might be wondering why the hell we ever want to do this, though. Anybody wondering that?
because you can steal methods, right? Like, I mean,
Exactly, right. So we've got these users here, right? So what if I go through all my users? How about we call this print hello message for user? And then we go through users for each. And we say user dot print hello message equals hello message for user. Okay, so and then here I'll show you what this looks like. We've now copied this function into the property print hello message onto each of these objects, right? Okay, and remember this thing uses this. So now we can come down here and say users.for each, for each user, user.print hello message. We're just going to call it. Okay, and what happens when we call a function using object dot syntax? What will the value of this be? It'll be the user, which means what will this dot name be? The user's names. So we should get Jared, Laura, Shaka, Peter logged out from this code. Jared, Laura, Shaka, Peter. Okay?
Yeah.
Shaka.
I totally understand why you're using this example, but I think it's not like a good idea to each object have so you would normally. This is not a constructor.
No, no, no. I'm avoiding constructors intentionally here.
Okay, cool.
Because they're not relevant. Constructors are the common use case for this kind of code reuse, right? We are reusing the function print hello message for user declared on line 8. We are using a copy of that for each user. So instead of declaring a new version of this function for each user, we're sharing code. We're using less memory because we're sharing that function. Constructors are a better way to implement that sharing, but the sharing that's going on here is almost the same. Right? Each user has a reference to this function, just like you see here, and we can call the same function from each user. I can come down here and just say users, whichever one I want, dot print hello message, and that's going to be Shaka, and we get Shaka's hello message at the bottom there, right? So I'm showing you how this feature of JavaScript, the value of this, is meant to be used for code reuse. It's meant to be reused in that you declare a function that uses this, and your intention when you write this function is for it to be called like this. For it to be called like object.property, called as a method. That's commonly what this is called. If we look over here again, this is being called as a function, and this is being called as a method on the Jared object. That's the difference between function and method. Is method has to do with an object. It's a method on an object, as opposed to inspect, which is just a function that lives on its own. So when we write this function, we intend it to be used as a method on user objects. Okay, and just to round this out, this is how you would normally do that, is you would say, I have a user function which is meant to be used as a constructor. Maybe it takes a name. Okay, and then we say user.prototype dot print hello message equals a function that uses the value of this, okay? And then instead of making users like this, we're just going to say a new user. Okay, and so look at what users look like now. Users look like, instead of plain objects, they're an object of the user constructor, and they have name and Jared, but they do still have the same ability to print that hello message. Okay, so the same thing's happening here. The objects that come back from here have this property on them, essentially. They have access to this property. And so when we say shaka.printHello message, we're saying call this function where shaka is your value of this. So the value of this dot name is shaka.name, which is the string shaka, right? So I did it manually for you, but that's the general case. Now there's way more to talk about with constructors, okay? But we have this concept of this. All right, one common use case that doesn't use constructors that you might have used before is we'll do like math.max.apply. So math.max usually is going to give us the max of any arguments that we pass it, okay? But what if I have an array and I want to know the max of the things in the array, right? I can't do this. I don't think this works. You can't give max an array. It doesn't, no. But you can give it each item as an argument, right? So we learned how to do that by saying apply, right? Remember, apply takes an array of arguments and we'll send those in as arguments. When we say math.max, we're saying the value of this for max is the math object because we're saying object.property execute, right? So if I say math.max, I'm going to say apply. I'm going to give it the same value of this, and I'm going to give it numbers as the arguments. And now I get back. So this is a tricky way of calling math.max.
By using call and just passing me the number.
Sure, I could, right? Here, if I want to do this, right? So this is how I would have to do it. This would be the same. So why would I do that?
Right.
Kind of specific, but like I was using apply to. So I wrote a function that tests whether a command is valid.
Okay.
For example, and it only takes one argument really is to test one argument. But to run tests, I actually just made an array of like valid and invalid arguments.
Yeah.
And I was trying to use apply to basically test that function.
Yeah, your question was you had some sort of like is valid command function that took a command and decided if it was valid. So let's just say this command is valid if it's either open or close. And we'll just say it's valid. The command you gave us is valid if it's in this array. And you were saying, well, you made an array of commands to test, right? And so we're going to test both open and close and explode and die in a fire and see if any of those commands are good. And so we'll go through for each command. We're going to record if it's valid, right? So you can just do this, right? Like expect to be false or to be true or something like that, right? You could do an array and go through. I wouldn't, if you're doing this in a test, I wouldn't make an array. I would just do a bunch of these. I would just say expect open to be true and close to be true and explode to be false. You know what I mean? I would just do it in a series there. But if you're doing it in an array, if you're like looping through like you're doing here, you also don't need to use apply because you can just pass command in like that. If however you needed to declare the value of this, you really only need to use call and apply for two reasons. One, you need to declare the value of this, or you need to somehow splat arguments out, right? In newer versions of JavaScript, this trick that we're doing here has a solution. You can actually do something like that. Newer versions of JavaScript support this splat operator, so we don't really need to use apply for splatting anymore. So now we only have one reason. Call and apply only need to be used if we're going to explicitly declare the value of this.
So with that valid is valid commands, like I've imported that from another file.
Yep.
Module, so
That's fine.
I wouldn't have to change the this value then.
Well, you're not using it, at least in the way I implemented a function you mentioned. If you're not using the value of this in here, then you don't need to use call and apply. Okay? But now, if we had something like this, like is valid, if we had something like is valid user, or rather, like we were doing before, like when we created a user, if we wanted, and we had this print hello message thing on it, right? And then we wanted to write some tests for that. We could actually come down here and say, how about we had another one here that just said like, user has valid name, right? And then we'll just say return if type of this dot name is a string and this dot name dot length is greater than 4. Let's say that's a valid name, right? So we can come down here and make our users, and then we can say users dot for each user console dot log valid name for this user. Okay, so everybody has a valid name, right? Let's add a user that doesn't have a valid name, and we'll see that one's false, okay? Now let's say I wanted to write a test for has valid name, right? So I import user into my test file, right? So I've got user here. I can come down here and I can write a test that says user with valid name is name Peter, and then user with an invalid name is just K, and I can say expect user.prototype.hasValidName when called or applied on a user with a valid name to be true. So this is how you could write a test for this, because we're going to take this function, we're going to take the function that we declared up here, and we're going to call it on this object. And so it's going to execute where this is that object and look at this dot name. So we're basically saying when you call this for this on this kind of user, expect this to be true and expect this one to be false. Okay? Obviously, we could also check this by saying like, that's another way we could do it, by constructing those objects and then calling the method on them. Here's a way to simulate a method call by saying take a function and call it on this object as if it was a method on that object. And these should yield the same code execution and the same results. So I spent a little more time on that than I wanted to, but that covers this and call, bind, and apply. There's a lot to chew on. I find this to be one of the two most difficult parts of, actually, this is actually really touching on the two top most difficult parts of teaching this language. I find it's difficult for me to teach and difficult, and I think therefore difficult for folks to understand, is what the heck is this? Why do we have it? Why is it in the language? And how do I declare what its freaking value is, right? I didn't talk about bind, actually. I do want to talk about that real quick. So we talked about all these different ways where we can declare both implicitly and explicitly what the value of this is, okay? When we call a function as a function, the value of this is default. It changes based on use strict. When we call it as a method, the object is the value of this. when we call it with apply and call, we explicitly declare what the value of this is, okay? But this, both call and apply, call the function right now. There is a third way where you can create inspect Shaka equals inspect bound to the Shaka object, which we declared up here. So now this is a copy of inspect that basically calls inspect.call Shaka, right? So if I call this now, well, I've got so much other crap going on here. How many things am I logging? There we go. So this last one here, I'm calling it on the Shaka object. You can see that that is working. I'll do it a bunch of times just to be sure. It's cool. So what bind is for is saying I want to make a new function that is a copy. It's not really a copy. It references the original. But let's make a new function that when called will do exactly the same as if I called this function on this object, right? And so there's the reason why we have to bind things all the time is because we end up being in functions that have a this value, and we're creating new functions, and we want those functions to also have a this value. And so that gets into callbacks and lexical scope inheritance and how we might preserve the value of this, which is another thing I'll say about bind is that the new arrow function is in a large part trying to replace one major use case for bind, which I don't have time to go into now. But bind is a third way to declare the value of this by predetermining the value of this and then executing it whenever you're ready.
Okay, so that's the major difference is that you can like basically set up a new function with bind and then you can use it later, whereas you have to use it when you're calling the function.
Yes, exactly. Okay. Bind is making a new function that's glued to a specific value of this, which you can then give away, and the receiver of that function knows nothing about that glue, right? But then call and apply have to be done at the time of execution.
You can't call and apply a function that is bound to something.
It will ignore whatever you give to call and apply because it's already bound. Yeah, bound function cannot be rebound. I don't believe that works. Because you'll get back a new function, and then if you're like, okay, well, what if I bind this again? I think it ignores that second one. Bind actually has some other features on it as well, but I'm not going to go into those. Cool. Ports. You wanted to talk about ports.
Yeah.
I mean, the short TLDR is that when a computer is on a network, it is given an IP address and it then is that address on the network, whether it's local or global. And then when you talk to an IP address, you have to pick a specific port that you want to connect on. So it's as if you have a house and then you have like 1,000 mailboxes in your house. You have a street address, but then you also have these like a subset of your address is these different mailboxes, right? So you're going to have your address, dash A, dash B, dash C, right? And so it's almost actually like your first name or your actual name, right? 5 people live at a house. You all have the same address. You have the same IP address, but you're a process, so you get port 3000 and you get 3001. It's almost like your name when we're thinking about the analogy of the U.S. Postal Service for how internet networks work, right? So, but what's really going on is that a computer gets an IP address on the network, and then it has thousands of ports at which things can be available at, and there is a shared standard across internet infrastructure of what different ports are sort of reserved for what. Like port 80 is the default port for the web. So when we go to a website like google.com, in the URL here, we could have put port 80 because that's the default port. Oh, actually, I'm on HTTPS, which is a different port, 220. Nope, 443. So HTTPS 443, you can see how Google is like, take that out and redirect, but that actually works. And if we were to go to a local server that we had, well, I don't want to set one up real quick, but if we had a local server running not HTTPS, normal old standard HTTP, it's port 80. SMTP has its own port. FTP, Postgres has a default port. MySQL picked a default port. So there's this like landscape of ports, and people,
Basically different protocols.
different protocols sort of bind themselves to different ports. And like Wikipedia is probably as good a place as any. Here we go. We're looking at different ports. So I actually probably said something wrong because I am not an expert in networking. So take what I'm saying here as like potentially fraught with errors, but because I'm seeing TCP and UDP here, so I must have been wrong about the fact that ports live on top of a TCP IP address. This probably actually has more to do with your MAC address and a lower level networking. At a lower level, ports probably exist in network. This is at the edge of my knowledge, but what you need to know to be a web developer is just know that a computer that's successfully on a network, if it's accessible via an IP address, then you can access different processes of that computer, of that network device via ports, right? So if I go into my preferences and I go into sharing and I turn on, is there not web sharing in here anymore? There used to be like web hosting as like a service that Macs did where they would host web pages. But anyway, there used to be a built-in web server that you could turn on and it would like host things in like a public folder in your home directory. That was running on port 80 on this laptop. So you could go to, on your laptop on the local network, access my local 10 dot whatever IP address and access ports on my machine. Also, if I'm running an Express app running on port 3000, if I'm not running a firewall, that's accessible from the outside. So if you know my machine's IP address, you can access my running Express app remotely by my IP address, :3000. So just like localhost, :3000, or here I'm running some local services. So localhost 8080 is a RethinkDB app that I'm running right now. I could also go to 0.0.0.0 port 80. I think that works too. You can also go to 127.0.0.1, which represents your machine. So there's all these different ways of identifying your machine, but then port is sort of what sort of, I don't know, one of many doors do I actually knock on when I get to your machine, right? And then certain ports are reserved for root on your files or on your machine. So I think anything below like 1000 or something is a special port. Like you can't actually turn on a process that connects to port 80 unless you run it as root. As far as I know, there's probably some way around that. So anyway, that's my spiel on ports. Any specific questions?
No, I just wanted to get like an overview for those that are. But yeah.
Yeah. So if you have two processes and you want to talk to them on the same machine, even not considering the network, even locally within the machine, even if I'm not connected to the internet. So I still have ports running on my machine. So if I can run two node processes, two node express servers, and have them talk to each other by doing an HTTP request to localhost :3000 or localhost :3001, and then those two local node processes can talk to each other via ports. So that's even outside of networking. Ports are still a way for processes to talk to each other.
So is that kind of what like sockets.io or sockets?
Yeah, so WebSockets I think are also on a different port. So I also could be wrong about this, but I think so. And you'll make a connection to a web server, and if it supports sockets, then you'll have a persistent connection open to that web server. So WebSockets might actually be, it might not be true for WebSockets, but certainly true for like web HTTP connections, right? When I do a Google search, my computer does a TCP connection to one of Google's servers and sends a message over that connection speaking the HTTP protocol, and that is going on a port to a real Unix machine. Any other questions about ports?
One more thing. So ports, so can you change port 80 to not be, web web applications.
Sure, I could host a MySQL server on port 80 if I wanted to, but it would really confuse any web server trying to talk to my computer because it wouldn't get back what it expected to.
Okay.
It'd be a protocol error of some kind.
How
Good.
can we know which ports are available?
Right, so how do you know what ports are running on your Mac? There's a command for this. OSX list open ports. Because sometimes I'll try to run my web server and it'll be like, that port's already taken. And I'm like, no, it's not. Because there's like a rogue process running around in the background. So sometimes I've had to do this. This is the one I'm used to, LSOF. So let's see what this gives. So I'm going to pipe this into my editor, and this is the output that it gave me. So I hope this isn't any special information, but you can see this is, where's the port number? Here we go. So 5900 is being used by LaunchD, and so are all these other ports. My local user is running different processes, like I'm running a Redis server and a RethinkDB and a Postgres, all at localhost this port. And so you can see which processes are running. So I'm running a couple of node processes. Dropbox is running something at 17500. I wonder if that's a web server. Doesn't look like it. So that's what's running on my local machine. So there's this LSOF command. I had to Google for it. You should Google for it too. And, you know, feel free to just copy and paste things from the internet into your computer and run them. That's never going to be a problem for anyone. So there's that way to do it. Another way to think about another way to answer your question, which if I didn't repeat it, which was how do we know what ports are available? Depends on what you mean by available. So in one sense, a port being available is nothing's using it, I can use it. Or another sense of the word available is like, this machine's running MySQL on this port, I can connect to that, right? So if we're talking about that latter external question of like, what ports are exposed on this machine that I can connect to, that's one of the main questions that people trying to exploit machines are asking. What ports are open on this machine and how can I get into it and hack it and break it? Oh, it's running an old version of MySQL that has a hack I know about. I can get in through that because you're running an insecure service on a port. That's how a lot of this hacking and connecting into machines is going on. They're running what is called a port scan on your machine. So if I'm running my Mac laptop at an internet cafe and I don't have my firewall turned on, someone can see that my laptop's on the network and just start asking, connect to port 1, nothing. Connect to port 2, nothing. And they start scanning and trying to connect to all my ports and seeing like, oh, this one connected. And I know it connected in such a way that tells me it's an old version of MySQL. And so people write these scripts that go through and scan all your ports, find out what's running, and try to exploit them. And they just have like years of exploits sort of built into these scripts that try to find a hole through one of the ports in your machine. And that's exactly what a firewall does, is it sees these incoming connections, sees that someone's trying to connect to MySQL on my local laptop, and I'm not going to allow that. And that's what a firewall is. So I think that's what this netstat is doing. I could be wrong, but there is such thing as a port scan that you can run on a remote machine to just sort of see what it's doing. But it's not a polite thing to do. If you notice your machine is being port scanned, you are probably being inspected in a way that you may not want to be inspected by someone else on your network.
And that would be illegal if I was.
I don't know that that's illegal to do a port scan.
That's how like those scammers and
Is a port scan illegal?
Is that how you do a port scan with that netstat?
I have no idea how to do a port scan.
How do you check if somebody's port scanning you?
So I don't know. I assume that if you're out there doing port scans on people's servers, it's possible that you will get in some legal conversation. I have no idea. I have no idea. So yeah, right. Exactly.
Wouldn't it be like going to someone's house and seeing if their windows can open?
Exactly. It would be exactly like walking up to someone's car and just checking to see if the doors are open, and someone's like, "What are you doing in my car?" And you're like, "Just port scanning." Like, not okay, right?
Just seeing if I
Yeah, exactly. But that's why we have firewalls, right? That's why it's important for you to have your firewalls turned on, because otherwise you might run a game that has an exploit. And if I'm running an application that is open on a port and someone knows of that exploit and I get found out, that's why people leaving their Windows boxes on just in their house and never running the Windows update is why we have millions of computers all over the world that are currently hacked and owned by spammers and spam bots and companies, essentially illegal companies that own millions of hacked machines and use them for nefarious purposes like sending out spam or whatever else you might need a swarm of 1 million computers all over the world to do. But that's because they're running old versions of Windows that don't have these patches, and someone has gone onto the internet and scanned every public IP address over months and months of time. It would take forever trying to find boxes that have these exploits. At least that's one way to do it. I am not an expert in this kind of thing. All right, that's enough about ports. Let's talk for 7 minutes about HTTP. So HTTP is a TCP protocol. So what I just poorly explained about the network happens all underneath this, right? Once I get connected to a computer at a port, I now can send it a text message, and that is going to be sent in a way that complies with the HTTP protocol, okay? So let's look at what that looks like. If I do a curl-v to https google.com, I get a little bit of information here. So curl is a command line HTTP application, and it made a connection to this IP address on port 443, which is the HTTPS standard port. We looked at some HTTPS security certificate stuff to get our secure connection, and then we sent this message. I need to get the slash path using HTTP 1.0. Here's the host I'm trying to connect to, right? Because the web server doesn't necessarily know what host name we use to get to the IP address, right? We used this host name. When I typed this command in, one of the first things curl did is it did an NS lookup of this domain, which gave us this IP address. That's using DNS, right? So once we translate a domain into its IP address, which is the whole point of DNS, we make a connection to that IP address, and then we have to tell it again, by the way, how I found you was because I'm trying to get to this. So take me there, right? Because one computer can host hundreds or thousands of websites, so we have to tell it what website we're talking about. And then we say, here's the user agent that's trying to make that connection. It's curl. And here's the kind of file I want back. I'll take whatever you got. That's the message that we sent. That's the request. And then the response says, okay, we're also talking HTTP 1.0. 200 stands for okay. The response that I'm giving you is good. I'm successfully responding to your request. Here's some metadata about it, some headers about the response. There's a bunch of good stuff in there, like cookies and cache control expiration, right? Google is telling me that its homepage should never be cached. I shouldn't keep a copy of it. I should ask every time I want it. And then an empty line followed by whatever the document is. This could be anything. This could be a JPEG. This could be HTML. This could be whatever. It's just whatever, right? I know what it is because the content type header told me it was text HTML. So I know once I start reading the bits after that new line that I should interpret it as an HTML string encoded in ISO 8859-1 character set, as opposed to like UTF-8 or something. But so that's an example of an HTTP request, right? So the anatomy here, the big parts here are we have a request and a response. Everything about HTTP is about a single request getting a single response. And HTTP is a stateless protocol, which means each request is completely and utterly ignorant of all other requests. So it means that every request and response is by default, unless you go out of your way to make it not a atomic idempotent request. It doesn't have any impact or isn't impacted by previous requests. unless we go out of our way to make it so with cookies and things like that, right? But by default, HTTP doesn't know shit about other requests. It just knows I got this request and I'm responsible for responding to it. Once that response is sent, everything is over, essentially. So we can compartmentalize our thinking about HTTP into one request, okay, and one response. So every request's anatomy has headers and an optional body. And those headers describe where I want to go. Well, actually, they have headers, but they also have what I want, and then a bunch of headers, like host and what kind of file I want, and who am I, and any cookies I have, and all kinds of other stuff. There's a bunch of other headers you can send, and then an optional body, which we don't have here, okay? And then you receive, to receive a request means you get a bunch of headers, and you get the path and the method. So let's write this stuff down. Anatomy of an HTTP request is method, path, headers, and a body. And within headers, these are key value sets. So that's the anatomy of a request, and the body here is optional. Okay, and then a response is a status code, headers, which are also key value, and always a body. I guess it's optional. I guess the body's optional, but almost always we're going to get a body. Okay, that's the breakdown. So there's a lot to know in here, and there's a lot, but it all fits within this structure. Every request and response follow these sort of basic structure. And if you want to start getting into what that looks like, the best place I can recommend you to do is to go into the Chrome Developer Tools and go to the Network tab, reload the page, and it will show you, as long as you have all selected here, it'll show you a list of all the HTTP requests that this web page is doing. So just to get this Google web page to load, I had to load all this other stuff. And there's even like a cool little waterfall of how long that took, right? Let's watch it again. Let's watch all those things start to load, and they're going in parallel. But let's take a look at one of these. Here's the very first one, type document. That's the request for the page itself, right? So we did a request to Google searching for is a port scan illegal. So if we look at our request headers, that's the URL. It's a get. This is sort of a general breakdown. Let's look at the request headers in specific, okay? And we can see, we know the first two things we talked about were method and path. That's right here. It's a 200. Oh, why does this happens to me all the time? Method. There we go. Make sure you right click on here and you see method selected because you want that column. So a 200 to, does this have path? Oh, I messed it up. Let me reload the page. I screwed up the ordering and I don't know how to put it back. Here we go. Okay, so the document request, the first request is a get request to /search. Question is port scan illegal to this IP address, and the request headers, look, here's our path, here's our method, we're going to google.com, we're sending it over HTTPS, and then look at these other headers. We're asking specifically, give us HTML, otherwise give us XML, otherwise give us an image, or whatever you got. So here's an ordered list of the preferences of what we would want in terms of the types of responses. Here are the cookies that we have. Here's the user agent, which is WebKit, Safari, Chrome. Like, user agents are crazy. This is Chrome's user agent. And then some other additional stuff. I'm not sure what X client data is here for. Okay, and then we can look at the response headers, which the server responded with these headers. Content type, we gave you HTML. Here's a cookie for you to set. Status 200, this was good. It's an okay response. And here's the response body, and we can also preview that.
Client data be the cookie?
No, client data is a special header, and I'm not sure why that's being sent along. X dash means it's like a custom thing. Let's ignore it. And so that's an example of a request that my browser did and how we can break down what are the parts and what do they look like. this Chrome Developer Tools network tab is really good for that. So that's all I got.
Thanks, Jared.
Thanks, folks.
Thank you, Jared. That's really good.